Okay, so my name's John Conti from Clearwater Analytics, and I'm here to talk with you today about Heroku, which is a cloud service. One of the reasons why I put together this talk, however, I'm not an expert on Heroku per se, but as a cloud service, Heroku has been extremely easy to use, and the more I've used it, the more appreciation I've had for it. And as a developer, it makes lots of tasks simple, and I would say that the service is developer-centric. And I'll talk a little bit more about how I got here and why I think that. But I think as a developer, it's fairly easy to pick up and go with Heroku as a cloud service. The barrier to entry is very low, and I think it's a useful product. I think it's the kind of thing that anyone can use quickly and easily to get reliable apps out on the internet. Again, this isn't an expert talk. I'm not an expert on Heroku, but there are lots of expert resources out there. And so, you know, learning about Heroku is actually fairly easy. It's mostly getting to know it that I think is a little is easy to do, but easy to think that it's complicated. So we're going to show what it's like to deploy an app, and on Hack Night, even if you haven't done anything, we'll get you up on Heroku without any trouble. So thanks to Clearwater Analytics for sponsoring this JUG meeting, and to Heroku for sponsoring our website. And in fact, I was using Heroku prior to them becoming a sponsor, but after using it for a little while, I said, this is great. Let's see. Bottom one. Okay. And so I asked them for sponsorship, and they were super enthusiastic. It took Heroku about 5 seconds to reply that they would love to sponsor us, and here's credit on the account, and why don't you guys get into production immediately? And so they're responsive. Most of the people who work there are developers, and so they sort of speak our language. If you have questions, interrupt any time. So I, like most people, started with an internet hosting account. You know, I think they're inexpensive. Almost everyone's used them. I think the tools that come with most hosting services are common across all of them. cPanel is a great example. And I started here too. But when I wanted to run apps on the internet, I started to find little barriers. I would find that the software wasn't well supported. There weren't very many choices or options. Often the modules that were installed in the hosting providers cache had security holes or were old, and it took support requests to get them updated. And it just sort of, it was a lot of work for not a whole lot of advantage. Now, of course, if you're doing PHP or WordPress or publishing a static site or downloading files, this is a really hard thing to beat. I used this particular vendor, HostGator, and I never really had a bad experience. It was inexpensive, it was easy to use. As soon as I went to write my own code, though, it was not a satisfying experience. So what I wanted to do was sort of move on and go to a place where I could write a significant amount of code and deploy it on the internet. So these were some of the things that I didn't like about a hosting service, and in particular, it was very hard to find anyone who would deploy a JVM. And that seemed kind of unusual to me because JVM is a fairly ubiquitous piece of internet software. So to not be able to write programs for the JVM and just put them out inexpensively was sort of a head scratcher for me. And the other thing that was true was these guys, host providers, are extremely efficient at providing a provisioned virtual machine in a given configuration. But if you need any different configuration, like say for instance you want to run something on something like Redis, or you want to have two machines work together with a worker queue, it falls apart super quickly. So they're a great option, and I wouldn't advise leaving a host provider if that's all you need. However, as a programmer, it wasn't a particularly satisfying experience for writing my own code. So why would I want to do that in the first place? Well, for me, tinkering with code is how I learn, and I think that's probably true of most of the people who code and build things. And it's important to be able to run apps that other people can play with to get feedback from them, to try things, to collaborate with others. Part of the community that is the internet involves our stuff being connected. So it's important to be able to do that, but in the same token, it shouldn't be a lot of work to do it. In other words, if it's a lot of work to put an app on the internet, if it's a lot of work to maintain it, and if it's a lot of work to apply patches and do security updates and things like that, that's all time that's taken away from the coding part. So for me personally, I want to tinker with the code. I don't really want to maintain the machine that I'm deploying to. And I had friends who did that, and their machines would get taken over, and they would get sent taunting messages from hackers, and they'd have to go clean up the mess continuously. And that was work I didn't want to do. So defining what I wanted to do was I wanted it to be easy. I wanted to deploy quickly. I wanted to manage my apps without a lot of trouble. In other words, I wanted to be able to take them down and put them up. I wanted to be able to migrate them. I wanted to be able to do all the normal operations without really having to worry about it. And but I wanted it to be always on, and I wanted it to be connected to the internet. So, and then maybe my wish list had a few extra things. Maybe maybe I might want to collaborate with someone. So I might want to build something with someone. Maybe we'd like to try a couple different machines, maybe a couple different configurations. Maybe we'd like to try some different software, stuff we hadn't done before. I wanted whatever I chose to support that. And in fact, if I started working with other people, or maybe donating my time, or trying to build a product, or whatever I was doing, I wanted to have all the facilities I needed to do that securely. In other words, to be able to grant access to a project without necessarily granting access to everything. So it needed to have some administrative controls, things like that. But so what I did is I set out and I started to look at professional hosting options. These are the kinds of things that businesses who run apps on the internet are likely to buy. This one, Engine Yard, I think is a Cadillac provider, but there are lots of others, and these are great. So the people who do these services know what they're doing. They're typically very experienced with a tool chain. They often give advice, and so you're likely to learn from experienced developers, and so they're a super option. I would say if one is ever doing anything for business, this is probably a very good way to go. But for me, I was really more of a hobbyist, and in particular, there were a couple things that didn't appeal to me about most of the pro options I looked at. For one thing, they were usually oriented around one or a few tool chains. So if you went to a Ruby on Rails host, you were going to get experts on Ruby on Rails. But then if you decided, the next morning that you were going to do Django or Clojure or something else, they weren't really the people you wanted to be talking to anymore, because most of these folks are specialized along a tool chain. The other thing is they're geared to businesses. They typically have a higher barrier to entry. They want paying customers that are going to drive revenue on their business. So typically they don't have some sort of easy way to get in. That's not completely true. There are many services that have a lower barrier to entry, maybe starting at the place where a hosting provider did. But still, you're going to pay money out of the box, whether or not you're playing for a hobby or not. They're going to want some money. So the next stop in my search was cloud providers, and cloud providers are a different kettle of fish. Of course, I have some big services up here, but for all these big services, there are about 1,000 little services. And these services are much harder to characterize. This could be a cloud provider nowadays, could be anything from someone who's got a rack of bare machines and you can provision them, to something that's a completely turnkey system which is relatively locked down. There could be something that you can scale to tens of machines, but there could also be services where you could scale to thousands of machines. And the pricing structure reflects this diversity. So there are services out there that have a relatively high barrier to entry. In other words, your initial service might be fairly expensive, but they might be cheap over the long run. And there might be other services that are easy to kind of get started with, but actually running an app would be fairly expensive. And there's everything in between. They're very flexible, they're very different, and so this spelled probably a lot of work. But it was the obvious choice because it's the only online service that actually had, pricing at the hosting level, but capability that was open to different languages, different programming environments. So I looked at this and I started to investigate it a little bit more. So I decided to dig in, and I did a fair amount of work on cloud services. And the thing is I would say at this point is there's so much diversity. It's an opening market. It's a little bit like a jungle. So there's every single flavor of service at every single different pricing range with every single different future product roadmap. And after you've spent a little bit of time here, I think it's pretty much dizzying, because by the time you've finished looking at the services that are out there today, they've all changed and you actually have to restart again. So it's a very hot part of the market. So I would say for most businesses, staying out of the cloud is probably a good idea, going with a pro host option. But as a hobbyist, I was still interested in doing this, and but I didn't want to pay for a big scalable option. Chances are I wasn't even going to use it. So I set about trying to sort through the options. And as you can see, I quickly became confused. There are some things that are easy, there are other things that are scalable, some things are cheap, some things aren't cheap, but I'm lazy, but I need more languages, and by the end I just didn't know what to do. The reality is, though, that if you look at the big providers from a pragmatic perspective, kind of more of a bottom-up perspective, there are really only a few choices. There are lots of new companies in the space, but for a person who's just a developer, who just wants to develop code, there's really only a few choices. And those are Google's App Engine, Amazon's Web Services, and I think probably very soon Microsoft Azure. And the reason why is these services have a fairly broad offering. They're accessible to tool chains, which are easy to own, and they all have diversity. In other words, you can run different kinds of things on all of these platforms. These platforms are really, really, really interesting. They're created by companies that are serious about doing ground-up development to support it. And there's lots of neat stuff in Google App Engine. If you've played with Amazon's Elastic Beanstalk, it's an amazing service too. I'm certain that Microsoft is going to bring Azure along very quickly. That would be their pattern, is to create a truly great service as well. So the thing that I found in using Google, though, was it was very powerful and very easy, but very sandboxed. There were only a few choices. If you wanted those choices, that's a good option. And Amazon's web services were incredibly diverse. There was lots of stuff you could do and lots of operating systems and systems to pick, but it was all work. You had to pick them, you had to start them, you had to stop them, but the full diversity was available there. So in the end, Heroku represents a compromise between those two extremes. I would say that Heroku is halfway between the convenience of Google App Engine and the flexibility of Amazon Web Services. So this is sort of a not too hot and not too cool kind of Goldilocks place for web services. In particular, you can't do everything on Heroku that you can do on Amazon Web Services. Even though Heroku is built on Amazon Web Services, it gives you a simplified turnkey experience on top of those Amazon Web Services. So you don't have access to everything that's in the Amazon Web Service sphere. In the same token, Google has a very restricted, they have a few languages, I think it's Go, PHP, Python, and Java. And within those, you can access the modules that they have provisioned and the services that they have offered to App Engine. Now, that's a nice set of services, and there's a lot you can build with that. So there's no reason not to choose that. Furthermore, Google is investing heavily in the platform, so I don't expect it to stay that way for very long. Plus, they have several new products, like I think they have a new compute product, which allows you to choose operating systems. Again, I would say for an individual developer, the complexity of that is likely to be sort of daunting. I would think you might end up spending more time doing development operations than doing actual development. So I think Heroku is a perfect compromise. So next I'm going to talk about how Heroku's assembled. So what are the working pieces and what do you need to know? So Heroku, as I said, is built on top of Amazon Web Services. And however, it offers sort of a dashboard web-based experience, which is closer to Google App Engine. Google directly courts developers, but if you need support from Google, it's really not there. In fact, the Google App Engine group, if you go to the Google group, they say this is all moved to Stack Overflow. They just have questions in Stack Overflow. So if you have a question, I tried to use this class, seems broken, there's no one there. They're not listening. And that's okay because frankly they have this tremendous value. So if you can get the value out of Google App Engine, I think that's great. Heroku might take a while, but there's a very active community of active developers both inside and outside Heroku which are supporting the Heroku platform. So we'll get to it in a little bit, but there are pieces of the platform that are open source. And this has created a larger sphere of developers that are more knowledgeable about Heroku. And it means that when you get into a jam, or more importantly, when you want to do something that's different or new, I think Heroku's a better place to go. The last thing is, Heroku is open enough that they've actually tried to draw other companies and players in to create add-ons. And add-ons are server-side products that can be charged to your Heroku account, but they are not built and supported by Heroku. The analogy I sometimes use is of Amazon resellers. Amazon sells a lot of products itself, but it also has resellers, and those resellers just sell through the Amazon system. The Heroku add-ons are a little bit like that. And so what's nice about this is it means that there's a continuing growth of capability on Heroku that's driven by demand and not just by what Heroku, the company, feels like deploying right now. So when talking about Heroku, there's a website called the 12-Factor app, and it's worth a look. It's a manifesto on DevOps and the way applications should be assembled to facilitate easy web operations. And I think it is one of the major inspirations behind the Heroku interface and API. And in fact, it creates a lot of simplifying assumptions that often create complexity in the server environment. And the 12-Factor app goes into details. There's a little sample here. But the basic idea is to simplify things and unify really the gap between development and DevOps. Often people develop code and then it sort of gets hurled over a wall into production, and there may be many misfeatures that make it difficult for production. In the same token, a very restrictive server environment often makes it much harder to write software. So the 12-factor app is an effort to reconcile these two different views into one coherent vision. And in fact, Heroku has used this in many ways as a roadmap for how to put together a sensible cloud environment. And just from using it, it's extremely effective. So here are some of the main components of Heroku at runtime. So this is what's happening when an app is running on the cloud. And this is simplified. We'll get into more details. But basically, in between any Heroku app and the internet is an HTTP routing layer. And this looks a lot like a reverse proxy like Nginx. It's got a caching layer. And in fact, it provides many of the same functions. But from Heroku's perspective, it also acts as a switchboard so that apps can be started, stopped, restarted without the traffic from the internet having any perception that the app has changed. And that's sort of an interesting thing. So Heroku takes care of all an app's interface to the internet. And that happens in the HTTP routing layer. And then behind that are the machines, virtual machines, which handle the web traffic. And these are called web dynos. And a dyno is Heroku's jargon for a virtual machine. And those in general are 64-bit Linux virtual machines, sort of a generic type of thing. There are several different flavors of dynos. A web dyno is different specifically in that it has this interface to the HTTP routing layer. So web dynos are the only type of dyno that can send and receive HTTP traffic. So, of course, to make up a working web system, there may be other kinds of tasks that aren't necessarily web-related. And so there are generally worker dynos. And these are configurable. In other words, you can have various different numbers and kinds. You can make them responsive. And they communicate with web dynos through either add-on databases, things like Redis, a direct queuing mechanism. So, for instance, there are quite a few queues. And another common communication mechanism is Postgres. So one add-on is made by Heroku, and it's the Postgres database. And I would say it's probably one of the most used parts of the Heroku system. So it's very common for people to use database tables to communicate between their app. That said, Redis is available, Q's RabbitMQ, lots of different queuing products and add-ons are possible. But in general, these are all the different kinds of components. So the routing layer is, I think, kind of an interesting thing because there's very little that an app builder can do about the routing layer. So you can buy caching, and you can set headers so that you get into a web cache, and you can deploy new apps. And when you deploy new apps, when your new app is running stably on a new virtual machine, the routing layer will magically change to point to that app. So most of the mechanics of the routing layer are completely transparent. In other words, there aren't any settings, and there isn't really anything to do. Heroku basically makes sure that you get the traffic when you think you're going to get the traffic. So Postgres. So one of the big add-ons for Heroku is Postgres. And I think that they've done a really interesting job putting together this database product. It's got a whole bunch of features which I find sort of attractive. They have backups and restores. They have slave database copies that can serve read traffic. They have specific versions of Postgres so that you can become compatible with one version and stick with it even if new versions are deployed. You can migrate by doing dumps and restores. You can also do queries, dumps, and restores over the internet. Or probably for most people, that would be to something like an S3 bucket or something like that. So Heroku add-ons, Postgres is an add-on offered by Heroku, but as I said before, there's a market for add-ons, and what I did is I went to their add-on website and just copied down the categories of add-ons that they have there now. And many of these are complete systems in their own right. So for instance, New Relic offers monitoring and graphing of real-time traffic statistics and things like that. And for instance, they have a free plan. You can actually just sign up, use New Relic, and they'll immediately start giving you information on your logs from all your apps. And then if you want to keep the logs for longer, you can scale up your plan as you go. Many of the add-on vendors have followed the model of Heroku, which is get something for free into the hands of developers so that they can see the value, and then charge them for the amount of service that they actually use. And so it's very easy with a lot of these add-ons to just fire them up, use them, see what you think of them, and then decide what you want to do from there. So lastly, I'd like to talk about how to use Heroku. And this obviously isn't going to be a tutorial on how to get started with Heroku, but what I hope to do is just describe some of the high points of the interface to Heroku. And in particular, I want to point out that it's pretty easy to get started with. It's worth going out and just giving it a try. So this is a diagram of all the Heroku components that are in play at build time. And this may be confusing because it's very common for Heroku apps to be built on Heroku. And so that's kind of a different model than most deployment mechanisms. Most of the time, one builds on their own box or a continuous integration system or something like that, and then you push the code to the environment where you're going to run, and away you go. And you can do that in Heroku, but that is a very uncommon use case for Heroku because Heroku has 64-bit Linux machines just sitting there with all the software you need, so there's really no reason not to build there. And in fact, when you build there, you make sure that a lot of the artifacts that you may need at runtime are actually present. So what Heroku's done is Heroku has created sort of a continuous build system that's hooked up directly to Git repositories on the Heroku cloud. So the way this works is the box of the programmer is out somewhere on the internet, and he or she has code, and they push it into a Git remote, which is a repository on the Heroku cloud. So the code moves into this repository, and what Heroku does is Heroku has a commit hook that runs at that time that then identifies the software that's been checked in and invokes what's called a build pack. And a build pack is really a set of build software that simply builds the software on a build dyno and then passes it to this system that they called a slug compiler. And what a slug compiler really is it's creating an archive of all the stuff that's needed to make a virtual machine with that software on it. So then once you have the slug is what actually gets deployed to a dyno. So you could think of it as an image that the virtual machine runs, or you could think of it as some sort of deployment package. We'll go into a little bit more detail on build packs, slugs, and deployment, but this is the overall flow. Let's see here. So as I said, code is pushed to Heroku with Git. So this is a little bit of a model of what that would look like. So you could have a Git repository out on GitHub, and then you have this Heroku remote. And of course, using something like Git, you can sync from any number of remote repositories, and then you can push the changes into the Heroku remote. And what's interesting is when this happens, the GitHub build process on that build dyno is actually connected to the Git process that's pushing the changes by a secure shell connection. And what this allows Heroku to do is to have an after receive hook on the Git repository so that as the build pack fires up and starts to build the software, you actually get output from Git showing your build process. It's a little unusual to explain, so I'm just going to show you. Let's see here. So let's see here. Can everyone see? Is this big enough?
A little bigger.
A little bigger?
Bigger.
Okay. Yee. That's not good. This one. How's that? Is that better?
Yes, thank you.
Oh, good. So as I may have said, this is we run the website for this jug off Heroku. And so one of the tasks to do after one of the meetings is gone is to change the date for the next meeting on the button that's on the front of the website. So I've actually already made that change. And so you can see our next meeting is March 20th instead of February 20th. So all I'm going to do is add that change. And now I have my changes in my local repository. So all I'm going to do is say, and this might not be the wisest thing, I'm going to push to production during this talk. But we'll see what happens. It's going to be either really cool or really awful. We'll see. So this is the website now. And you can see the button says February 20th. And if I go back to our shell, you can see that the repository has been committed to, and it showed us that it did that. And then immediately afterwards, it said that this is a closure app, and it is. And it immediately went and found the build pack that goes with the closure app, and it called that build pack in the working directory of my application. And so it compiled the app, and then afterwards it compressed it into a slug, which is 75 megabytes. And then it said, I'm making a new version, and I'm going to launch. So it is deploying right now. And what it does is yeah, Brad.
Yeah, it looks like you made this one little change that recompiled the whole app.
So it's a good question. So underneath Linigan, in this particular one, is Maven. So in general, the working directories will get blown away, so my own app binaries will almost certainly be recompiled. But any of the Maven dependencies that I have are very likely to be taken from their own Nexus cache that's there. And so that typically goes pretty fast. So as you can see, this build goes pretty fast, and in fact, this build is actually faster than it is on my machine. So what happens is it created a new version. It says version 104, and we'll come back to talk about what precisely a version is, because it's not exactly equal to what a slug is. And it deployed it. So now, with any luck, we'll go back here. We'll hit Control R, and the buttons change. Whew, that was good. So, this isn't a perfect system. There are some downsides. Obviously, when there's a build problem, it's happening on a remote machine. But it turns out, actually, you can SSH into these machines. It's just a remote shell. So it's actually fairly easy to debug. Or at least as easy as it is, I think, in any other continuous integration or remote build machine. It's certainly no harder. So I want to talk a little bit about the build packs. The first time I saw that myself, I thought, wow, this must be like this huge, amazing piece of software, a build pack. I'm imagining stuff. So one day I actually cruised out to the internet and looked at the build pack. They're all on GitHub. They're open software. And I looked at the build pack for my app, Closure, and it was a bash script that was about 20 lines long. I was really blown away by this, and I said, well, how could this be? I mean, this has got to be a complicated thing, right? Well, it turns out there's a whole ecosystem of build packs, because for the most part, it's the stuff a person or a continuous integration build service would invoke on a 64-bit Linux machine to build software. It's actually not that big a deal. And in fact, the ones in this purple box are the ones that Heroku actively maintains and supports themselves, but they themselves support a whole bunch of open source developers which have their own build packs. So there's build packs for core data and build packs for Go and .NET and all kinds of things. Because at the end of the day, it's not an operation that developers aren't already familiar with. So lots of developers can create build packs, and in fact they do. These are open source. You can go browse them, and in fact you can get them changed, or you can modify them yourself. There's no reason why you can't build with your own custom build pack. At the end of the day, it's just something that you install into your Heroku environment, and then you associate it with the type of application. So we'll go through that more in a few minutes, but it seems like rocket science, really isn't. So another thing that's really common with persistent internet apps is database. And like I said, Postgres is sort of a top tier add-on. In fact, calling it an add-on's maybe a little silly because it's a key part of the Heroku system, and it's got lots of first-class support. So I won't go through all of it, but there's some stuff that I think really impressed me. One of the first things is Heroku has, like many databases, a command line shell that you can run queries. It's called PSQL, and just like the build pack, it seems complicated, but in fact Heroku makes it pretty easy to just run PSQL against your database that's actually running on production in the cloud. And in fact, you can have, I think, up to 10 active databases for any Heroku app. And so you could connect to several different databases. You can copy between databases. And in fact, you can run a whole lot of tools, not just this command line, because what Heroku does is it offers you a connection string that you can get from this command line tool called the tool belt, which allows you to connect with all kinds of like visual database tools. So what I did here is I said, Heroku, give me Postgres PSQL, and it said, fine, here's your database. So I can say, let's see here, I better not go off script. That usually doesn't go well. Let's see here. So I can ask it for what tables I have, and in fact this is my tool, my instance of PSQL running locally on my machine. And I can also do something like, okay, we have one table out there with survey. How many people have filled out the survey? And it says we have 44 rows in that table. So for Heroku gives developers databases on shared hosts with up to 10,000 rows of storage for free. So you can get started immediately for no money and make tables and start building an app. Obviously, if you're going to store more data in it, you won't want to share your database server with other folks, and you'll also want backups. And there is a charge for it, but there are about 10 tiers of service, and they range from the super inexpensive to fabulously full-featured. So moving back here, there's a bunch of tools. You can pull an entire database straight from the cloud. You can capture a snapshot remotely and do a restore later of the snapshot. You can also point the Postgres restore to any HTTP accessible dump of the database. So for instance, in this last example, I'm saying I need to restore my database from this Amazon S3 bucket, but it could be, any URL. So that's useful for migrations, it's useful for analysis, it's useful for doing local testing of real production data. There's really just a tremendous amount of utility here. So I want to go into some of the details of what a Heroku app looks like at runtime. So I talked a little bit about compilation into a slug. I want to go into quick details here and show what happens when you push your code into Heroku. So for one thing, we've pushed our code in and we compiled it to a slug. Now there was one little file in there that's part of every Heroku app called a proc file. What a proc file does is it associates the name of a type of dyno with a command that starts the software that you want to run on that dyno. Now, as I said before, there's one special kind of dyno, which is a web dyno. What's special about that is it connects to the HTTP routing grid. But you can create ad hoc, arbitrarily named dynos for the different parts of your system. So you might have a worker, and you might have a some process devoted to Twitter, another one devoted to analytics, and you can define what all those different types of dyno are in the proc file, and in particular the commands that invoke the part of your software that are to run on those dynos. So the proc file defines what parts of your software correspond to what parts of the system that you're working on. So the proc file is part of the slug, and the other thing that's an important part of what Heroku views as a release is the environment variables. For instance, on our Java Tech Boise site at the bottom here, we have a stream of our tweets. And Twitter has issued some keys to us that allow us to download this traffic. But we don't put the keys in the source code. What we actually do is we put them into environment config variables using the Heroku tool. And Heroku keeps those safe. And when Heroku starts up the dyno, it makes those environment variables available to us and several others, including things like the port number that will be connected to and things like that. So what goes into a release is a set of environment variables and a slug, and the slug contains the proc file. So if I go and I update the environment variables, that actually creates a new release. And the reason why the releases are important is because they're named and they're my unit of rollback. So if I push code in, it makes a new release, it puts it out there, and if I say, oops, that was not a good thing, I say, Heroku, please roll back, and I give it the previous release number. So the other thing that is important here is scaling. So Heroku doesn't make any assumptions about which dynos you want to run. It assumes you probably want to run a web dyno, but it doesn't assume that. What you set in your configuration also is how many of each kind of dyno you want to be there. And what's kind of neat about that is you can do it statically. You can say, I want 2 web dynos and 1 worker. You can set that and forget it if you want. Ours is set to 1 and 1 or 1, and it just works. But you can also change this anytime you need it. So for instance, you might want to scale your app, you might want to test at a higher scale, you might want to do load testing, or you can use their remote API to actually control your app based on things like what the logs are doing. And we'll get into that in a little bit when we talk about the job scheduler. But there's lots of different flexible ways of scheduling apps, and it's as easy as putting in a command line that just says, Heroku, scale my web processes to 3, which is that bottommost invocation, if you can see it. So I mentioned proc files. I'm just going to give a few little examples of proc files. The top one is the proc file from our site. So we run a Clojure site, and using Clojure, you use a tool called Lineagen, which is abbreviated LEIN. And so to invoke the web process for our website, you just say lean ring server. And that's exactly what I type on my local machine to start it up when I'm developing it. So really all I had to do was say, Heroku, I'm going to have a web dyno, and this is what you do to run it. And just in case you may be not familiar with Clojure and you think that's fancy, the next one is just starting a shell. So the next example, sh target bin web app, that could be a Maven assembled Java app. So you assembled it with Maven, it's in that directory, invoke a shell script that just starts main. And then you can go and you can resize the workers, you can down them, you can up them, you can roll them back, you can push them forward. So it isn't just cloud processes serving long-running apps. I said that you can connect to like a build dyno with an SSH, which is super useful for the build packs. But you can also run arbitrary ad hoc processes. In other words, you can just say, Heroku, I want to run this process. Now, it needs to be something that's already compiled into my slug. In other words, Heroku has to have the software to invoke. But it doesn't have to be defined previously in my proc file. It's not a long-running process, so Heroku doesn't need to know about it in advance. It could be just a Java class, it could be a Python file, it could be a Ruby file, and furthermore, I can pass command line arguments to it. And I can run it just as a one-off, go do a database checkpoint. Or I can connect to it with a shell, run it, and then keep giving command invocations. Now, one important point is Heroku makes no promises about the file systems on dynos. So the software that's running on a dyno can write to the local file system. And this is handy for things like temp files and stuff like that. But in fact, none of that data will survive the dyno. And in fact, dynos, you can push changes. Your old dynos can be downed at any time and new ones brought up. Heroku, because it has this big switchboard in the HTTP routing layer, they could say, well, we have to take that rack down. We're going to just move all these apps to new dynos without them even knowing. So you can't really count on anything in the file system. So that's one thing to be aware of.
So then what do you do with user files? User uploads images and whatnot. You have to send that off to S3 somehow.
Yep. You have to provide for your own storage. So you see lots of stuff going into Postgres. You see configurations where Postgres point to S3 buckets. You see configurations where Redis drives queues and Postgres has the data, and then there's background process that periodically buckets things up into S3, and probably everything in between. So scheduled processes. So lots of server machines use things like cron or scheduled processes for maintenance. Heroku's comfortable with that. There's a command line scheduler that can do that kind of stuff. There's also a web-based scheduler, and the web-based scheduler is kind of nice because people who are less comfortable with the command line can just change when it's going to run. It's human visible. You can have lots of different jobs, and you can keep them off and just turn them on when you need them. It's fairly easy to use. I want to talk about logging a little bit. So if you've had any experience with Java or .NET applications and logging, there are lots of frameworks for logging and add-ons for logging and tools and providers and databases, and it seems like collecting log messages turns into this really big thing. And Heroku's done a really nice thing with logging. Any of your software on any of your dynos just outputs to standard output, and Heroku gathers all of that up, time-stamped, and blends it with all the data from the infrastructure. So if your app migrates a dyno, there's a log entry that says when it went up and when it went down, and what release was started, and all of the logs from all of the machines are aggregated and time-stamped and presented in one time stream that's accessible from the Heroku tool as just standard out. So you can just say Heroku logs, and you just get your logs. Now, Heroku only keeps a little bit of logs. So if you want long-running logs or data analysis or other things, there's a whole bunch of add-ons that can be used to increase the amount of storage or offer full analytic solutions. But either way, from a coder's perspective, you don't need to have add-ons. You don't need to do integration software. You can log straight and synchronously with all the other things that are going on with your apps from a bash shell by just saying echo standard out, and you've logged. It's done. So I really like that about it. Another neat feature is something called data clips. As I said, Postgres is really a first-class resident of the Heroku cloud, and this is one of the nice features. So data clips are like a view. It's a continuously running, and I'm sure it's polled, but it looks like it's continuously running query against your databases, and then it's accessible via the web with an obfuscated URL. And what this allows you to do is to retrieve the results of the query as JSON or XML or CSV. And you can even do it from running web apps. It implements a system called CORS, which is a system for allowing cross-site scripting. So if you have JavaScript running on a different domain, you can get access to this essentially live SQL data. It's a really cool feature, and you enter the queries straight through a web-based interface. So I think that's it for my 3 sections, and I wanted to just say that this, especially the last part, is kind of a whirlwind tour of the developer parts of Heroku. But we're gonna have a hack night in a month, and we'll be able to get anyone who comes, up with Heroku. We'll get some code running on the cloud, sign you up for a free account, and you can, get started if you'd like. That's it for me. Any questions?
When you need to store files, for example, do you get a certain amount of S3 storage for free too?
So I believe that for code, the slug size is the variable, and right now they cap it at I think 800 meg. So when you sign up for a free Heroku account, they basically give you 10 free apps, and that means that you can create SQL databases with up to 10,000 rows, and you can push as many revisions as you want, really. But they are limited to 800 megabytes in size. So if you, for instance, had a lot of assets, images or something like that, and it started to outgrow the slug size, you would want to probably buy an add-on to a CDN, a content delivery network, and install your assets there, and let those assets be served up on either the local Amazon network, or many CDNs are actually distributed geographically, so that.
Oh yeah, that was another question. Yeah, Amazon has all these different regions around the world.
Yeah, right.
Can you deploy Heroku to region?
So I believe that Heroku has some flexibility about this, but I don't know what the flexibility is.
When you create your app, you can specify if you want it in the US or if you want it in Europe.
I see.
Yeah.
Cool. By the way, we have someone with a lot more experience with Heroku in the audience, so pepper him with questions as well.
When it comes to like assets and everything, your best bet is to throw it on S3, like for your JavaScript CSS files and images, and then throw CloudFront in front of your S3 bucket for caching. Just because by default, Heroku is not going to be doing as much caching when it comes to CSS JavaScript files.
Yeah. Yeah. Heroku does I think they do a really great job, but they don't make specific promises about what the caching is at various places.
So can you get set up with Heroku, and then can you kind of get in behind the curtain and directly into the Amazon stuff if you need to?
Well, so one of the nice things is, in the end, a dyno is really just a Linux 64 instance. Heroku doesn't really have any lock-in to you. So if you decided that this wasn't the service for you, I mean, you're running in the same environment that you would be in Amazon.
I mean, can you get to the other Amazon's controls and stuff that whatever?
No, I don't think you can.
You get to it.
No. The interface, it feels a lot like App Engine. You've got some command line tools, and you've got some web-based tools, and you've got some add-ons, and that's really it. But I would say that's why the result is simpler.
Yeah, if you wanted to do what you're talking about, then you would just move to Amazon or the Elastic Beanstalk,
Yeah.
which is AWS's simple app deployment setup.
Yeah.
So many different things I can't figure out what's what.
Yeah. Yeah, and Elastic Beanstalk is a really terrific product. To say it's more complicated than Heroku is not fair, because it is a simple experience too. It's just less automatic. Yeah. Yeah. All right.
I got a question
Yeah.
for you.
Sure.
Let's say the Java tech site had, you needed to minify your JavaScript or pre-process your CSS. How would that fit into the Heroku model?
So you need a build pack to support it.
Okay.
And so build pack authors have to work with Heroku to figure out what tool chains will actually be installed on the build VMs. And so Heroku has a whole bunch of data on their site about what's installed on the VMs, and they have a support channel that basically allows build pack owners to get regular assets that they need, make them permanent copies on the VMs themselves. So there's a process for doing that. Of course, until that's done, then what you have to do is you have to, a lot of times, put the tools into your source code so that they can be used by the build pack. So the mileage is going to vary by the build pack. What I would say is, in the case of JavaScript minification, you're probably in good shape. A lot of people are going to need that and want that. I would imagine it'd be well supported. It's also possible that you need something a little bit more esoteric, and you might end up having to package it. Yeah, I'd work directly with those open source build pack owners on any special stuff.
Yeah, you can configure an environment variable in Heroku to hold to your build pack instead of using their default build pack. So for example, we were talking about caching dependencies. I ran into an issue once when it wasn't releasing the So I just wipe out everything on every single dev deploy. So yeah, you can configure them and host them on your own GitHub account.
Yeah, and it's really cool to be able to just go browse the source. Say, wait a second, this was working fine, what changed? Well, the build pack may very well have changed. It's essentially an outside dependency that's living there on Heroku. So I can push my code and everything's the same, but the build pack's changed. So, you know, it's something to be aware of. Yeah. All right, thanks.